All right, welcome back. We are COMP123 in the summer 2020 semester, and it's week 5, part 1 of our broadcast. It's all around polymorphism this week. But before we get there, let me talk about the schedule a little bit and some changes. So I'm going to go to this slide here. So this is kind of the same deck that I used for week 4. I've just cut it down a little bit just so that it has everything we want to talk about. So this is where we were last week, and again, stuff we still have to cover are partial and nested classes. We'll get back to that. And this week we're sitting at where it says exception handling. Okay, so but instead of doing exception handling, I'm skipping forward, and there's a reason for this. I'm just swapping out some of these. The lectures are going to be slightly in a different order, and the reason for this is because I wanted to give you an assignment based on polymorphism and interfaces, and I can't do that unless I show you the stuff. And then what we're going to do is we're going to continue. I'm going to cover everything that you see here. It's just in a slightly different order, and I'll tell you, what order it's going to be as we get there. So, so again, we're sitting at notice it says polymorphism is like week 9 in that range, because here's week 8. I'm not sure why, but my week 9 is kind of missing, but it's here. That's where it is, polymorphism. And then, in the last few weeks of class, we're going to be talking about Windows forms and controls. So I need to build you up for that time because of some stuff I want you guys to do with visual controls. And that's why I'm getting you to do polymorphism and inheritance interfaces and all that stuff early. Okay, so we're going to get back to it. We're still going to hit all the stuff that we talked about here, file I/O, serialization, test-driven development, all this kind of stuff. It's just a matter of the order that we're going to get in before we get there. Okay, and there's a reason for this. I think it's a natural progression to go from, here's basic classes. Now we're going to get to inheritance and polymorphism, and then into interfaces and abstract classes. Okay, so we're going to get that first. Then we're going to go in and add stuff. Adding stuff like file I/O and serialization, I mean, really, for the most part, you could have done this in the first semester. Test-driven development is something we're definitely going to hit, but we're going to do it once we have all the class stuff in place, and we'll get there. So a little bit slightly different order of stuff than what you see here. We're still going to have test 1 on week 8. That's still going to happen. It's just the material for test 1 is going to be based on the stuff that I've been talking to you so far in this order. And of course the things that you've learned with Professor Rendra. Okay, so without further ado, I'm going to get to some review. So last week we talked about this idea of classes as blueprints. Okay, so we can imagine if I had a house, right? And I always like to think about this as a kind of this analogy of the house. So blueprints are really, really important when we do construction, right? I mean, we have to really plan the room size in order for us to to construct a house. So part of it is not just planning the room size, but if we're going to have more than one floor and so on. And so these blueprints or prototypes are the things that we use to build instances of houses in real life. And that's what it is. It's like we use the same blueprint to build multiple houses. Each house might have different inside characteristics, though. For example, the inside might be decorated with different colors, different trim, of course different furniture, all that kind of stuff. And that's similar to what we do in classes when we program. Okay, so that's kind of the idea that I want you to keep in your mind. So again, you can think of here's a house beforehand, and then what we're going to do is we're going to take that original house, based on the original blueprint, and extend it. So we're going to add, let's say, another garage, right? And this idea of extending the house, I like the word extend, because really when you think about it, what it means is that the house that is derived from the base house or the base class is going to get bigger or fatter. And that's what I was telling you guys last time with that last diagram that we made together. So children are always bigger than the parents, always, in inheritance from a programming perspective. It doesn't matter what language, by the way. It doesn't matter C# or C++ or Swift or whatever modern language you can think of. So the idea is that we have more specialization as we go down the chain, like we talked about. So we start off, as an example, with an animal, right? Here as an example, and we see that there's some kind of hierarchy, right? So animal, there's two types. You can go, let's say, mammal and fish, right, as an example. I guess fish is an animal. I'm not sure if this is a great hierarchy, but if you think about this, then fish and mammal have a related ancestor, which is animal. But fish and mammal are differently specialized, where a fish can swim, a mammal can walk. And then from a mammal, there's different kinds of mammals. There's some airborne mammals, birds, as an example, might be some kind of, if there's some kind of birds. Mammals, this is an interesting hierarchy, because this is not exactly how it works in real life. But because birds, I mean, there might be some birds that are mammals, but most of them are not, right? So we'll talk about that. They need to be warm-blooded, they need to have hair. There's a bunch of other categorizations and stuff like that. But you can see that as we go down the list here, that there's different kinds, and you continue to specialize. And if you notice, if you went all the way down, if there's such a thing as a parrot being a mammal, if there was, then a parrot is a more specialized mammal than way up here in the ancestor chain. Okay, so this kind of idea. We drew it a little bit like this. So we talked about star UML a little bit, and there's different parts to a class. The top part would be the class name. The middle part here, as an example, would be the private instance variables. Then we get into the properties. And finally, at the bottom, we have some kind of operations or procedures, methods. There's different things that they're called, right? The arrow that points up from the commission employee to the employee is really the inheritance arrow, if you think about this. I'm going to call it the inheritance arrow, but it's really an association, a direct association from the child class to the parent class. Okay, so that's how we draw it when we plan our classes. A couple things that we talked about last day, just as a review. We talked about the idea of a base class, also known as a superclass or a parent class. A derived class, also known as a subclass or a child class, as an example. So there's different ways of naming things, but one thing that we want to talk about and remember is that a child or a derived class has an is-a relationship with the base class. So for example, we can say that a student is a person, right? Like we made that example last day. Okay, so, and this idea of inheritance as part of a big chain, an inheritance chain. Some people like to think about inheritance as a big domino effect, and I think that's a good way of thinking about it as well. So we change something. This is the disadvantage of inheritance we talked about as well, which is when we inherit stuff from the base class into our derived classes or child classes, then if I make a change to the base class, then the chain trickles down and it triggers a change throughout the entire inheritance chain. And the problem with this is that if I make a breaking change, something that maybe I add a parameter or remove a parameter from a function or something like that, a method, and if another function is dependent on that previous function, the way it worked before, right, then I can have something called a breaking change, which is something we don't want in our code. And that's kind of a disadvantage of inheritance. So what are we talking about today? More about the protected access specifier, how we can override our base class members. How do we do that? Because we're talking about polymorphism today. More about how a derived class is an instance of the base class. We want to talk about the object superclass. The object superclass is the superclass of all superclasses. Okay, and by the way, the object superclass, it exists in one form or another in every language. Okay, so that means that if you're learning Java, or if you're learning a JavaScript, or if you're learning Swift, like I said, or C++, there's always something like an object superclass. It really depends on the language. Okay, most of the time it's just called object. But the object superclass is like, think about the root of all classes, the progenitor, all right, if you will, to all other classes. And it has some basic attributes that everything inherits from. Okay, even if I make the new class, if I say a new class, by default, its parent superclass, or if you want to call it the base class of all classes, if I make a class, is the object class, right? So that's interesting. And so we can always check to see that any class is an object superclass, right? So that's kind of a weird thing. And we're going to get to this thing called polymorphism today, all right? Which is, we talked about last day, polymorphism. I'm a Greek guy. This is a way for you guys to remember where poly means many and morphe means form. Polymorphism, many forms. So a class further down the line, a derived class, can override or hide methods from the base class or superclass, and the new methods can warp or mutate to take on different forms. So the implementation of the overridden class, even though it has the same method name and the same method signature, right? When I override the derived method, it warps or mutates, so that way it'll be different implementation wise. And we did do this because we want to further specialize when we do when we implement inheritance in our classes. Okay, further specialize. And why? Because we talked about this last day, the idea that I have a toString method as an example, and toString works well for one class as an example in the inheritance chain. But as we further specialize, we continually have to override the toString method because it may not work exactly how we need it to, right? For the classes further down. All right, so that's why we have to continually specialize and warp. I like to use the word warp or mutate the classes further down, the methods further down. So here's some examples of this. We're going to get into the programming part in a bit of a demo, but I want to go through this. So again, you have this class student, and again in this instance of the student class, and notice that this student doesn't derive from person. But one thing to know is that we can mark methods or even properties as virtual. Once I mark a property as virtual, by the way, this is the same in some ways as C++ and in other languages. We mark a property as virtual, and then it can be overridden. It doesn't have to be overridden, but it can be overridden. And what this means is that I can change how the implementation features, this down here, is going to work later on. So let's continue down the line here. So here's an example of that. We have class scholarship student. It extends the student superclass in this case, so a different kind of student, more specialized student. And then what we can see is we have a public property, right, that returns an integer, okay, which is credits. That's the public property. We have a setter for credits, but notice that there is no getter in this case. So a set mutator, not a get accessor. Okay, we talked about getters and setters last week, right, with just different words, right? So set, whenever we set something, we mutate something. Whenever we get something, we access something, right? So here what we're doing is we're saying that credits, and this could be a private instance. And if you look back at the inheritance chain, you can see that credits is a protected integer, right? Now again, I also talked about the perils of protected. We don't want to use protected too much. Protected is a once in a while thing if we want to solve a problem. We want to try and do private instance variables and public properties as much as possible. However, this is maybe one of those instances where I want to access credits. If this was private, then my derived class couldn't, access it like this. It would, if you tried this in the derived class, and if credits was private and not protected, right, then it would give me an error. It would say, sorry, but you don't have access denied to change your, the value of credits. In this case, credits is a private, if it was private. And this is why when we talked about last week about code conventions, I talked about how it's so important how we name our variables. Because here, can you somehow know in this example that credits is a private variable? The answer is no, right? You can't really tell. I mean, it's a variable, we know that, but we have no clue that it's private or protected or anything. And this is why we have to change our conventions. The other thing, if you notice here, is that because the set mutator method here is, which is inside of the property, the public property credits with a capital C, right? Again, think about the public property as the front face of the credits data field. Okay, that's what it is. So this is the front-facing version, right? So users of the scholarship student or even the student class only see credits with a capital C. They don't see credits with a lowercase c. This credits with lowercase c is private or protected in this case, right? But notice that the set mutator does not just sets the value of credits, but also sets the tuition to 0. So there's two things that it can be done, and many, many other things if I want to, and with using properties. And that's why we use properties over direct access to the private instance data members. Okay. So going back to this then, if we override, and if this was, here we have a class, a demo students, and this would be like almost like our program class, our the class we would start things with. Notice that student is, we just make a new instance called paying student, which is a new student. And we have scholarship student, which we make a new instance called free student, which is a new scholarship student. Notice that student and scholarship student, these constructors are the default constructors. Why? Because they don't take any parameters whatsoever. Okay. So here's paying student name is equal to Megan, and paying student credits is equal to 15. You can see that credits, we're using the access mutator, right? Set the setter, right? That's what we're doing here to set the credits 15. And then free student name is equal to Luke. We can still use the same name property, even though we haven't overridden it. It's still part of the class structure, and so because of that, it gets inherited by the other class, the scholarship student, down the line. Okay, so again, Luke and the credits 15, they both have the same number of credits. But if I do a console write line as an example, and I say something like paying student name and paying student tuition, and then toString, and if we did the same thing, so toString C means currency, of course, and console write line, as an example, zero's tuition is, and free student.name and whatever, you get an output that says that Megan's tuition is $836.25 because we have a ratio for that, but where Luke's tuition is 0. Why? Because if you go back up the chain, when we modified this, when we changed the set accessor method only for the scholarship student to set the tuition to 0. And that's how it works. That's how, it's a good example of polymorphism. Okay, so let's get back to that example. I'm going to redo some of the stuff we talked about last day. So here I'm pulling up Visual Studio 2019 with you. So please, let's get back to this. We're going to make a new project again. I know some of you also sent me some email over on Friday, of course. It's always on Fridays when everything is due, and you're like, Professor, I'm having a problem with GitHub. I'm having a problem with this. I'm having a problem with that. And I can't make a repository, or I can't do a GitHub account or something weird like that. Everyone can open up a GitHub account, but sometimes what happens is a repository, if you create it wrong, especially if you create it in the wrong order. Let's say you create a repository online on GitHub first, and then you try and connect to it with Visual Studio, that can lead to some issues. And I'm going to talk about some of those things. We'll actually do the other way today, so I can show you how that works. And I'll give you your new lab on Wednesday. Okay, so let's take a look at this. So I'm going to make a new repository or a new solution. So create a new project. Again, I'm using Visual Studio 2019, right? There's two options. Console app, by the way, you can also choose what type of thing I want. So console app.NET framework. There's also other languages that I can support, but I'm not going to do C++, obviously. Let's go back and do a .NET framework, not .NET Core. .NET Core is really for web. .NET framework is for what we're doing. Okay, so clicking that, click next. Again, from a project name perspective, we're going to name it the same way. So COMP123 in the summer 2020 semester, and it's lesson 5. Let's make this lesson 5 part 1. Maybe we'll do another project or solution on Wednesday, right? So just to keep us, give us a little bit of flexibility there. I've chosen .NET Framework 4.7.2, and it says the solution name is the same. I can change the solution name now. Even though the project name is this, I can make the solution something different. And sometimes some professors, what they'll do is they'll make multiple projects inside of a single solution. Not going to do that here with you. All right, I'm going to click Create. And now Visual Studio is going to do its dance and create a brand new project for us. Okay, guys, I'm going slow because some people sent me some mail saying it's a little bit fast. You know, as an example, we learned it slightly differently with Professor Narendra, or very differently. And, you know, struggling to try and understand what to do next, you know, and whatever. Totally understand. That's why I'm going through this again with you guys, not now. So that is where we start off. So if you notice the program class, remember this is the entry point of your entire application, right? And we're going to get back to this one. So again, there's a couple things to do here if I was going to set off GitHub. One is if I start GitHub off here, Git in GitHub, if I add to source control down here right now. So what this does when I add to source control, right? It's going to create a first commit. That's what it's going to do for me right away. All right. So it's going to do some of the commands I talked about last time. It's going to do git init, git add dot. This is all the stuff that Microsoft's Visual Studio is going to do in the background. Git commit -m, and it's going to do two commits. One which is a dot ignore, a git ignore, and the other one which is a kind of a configuration, another configuration. Okay, so that's the two things it's going to do when I click this button down here, add to source control. I can also add to source control up here in solution. So if I right click on my solution, and if I go to add solution to source control, you know, this will do the same thing. As soon as I click this button, the solution is going to do those three things in the background. Okay. So let's do this now. I'm going to click this add solution to source control. My solution is pretty much empty, right? So it's a great time to do this. Before we start, I now have source control enabled, which means any changes I make locally, right, are going to be tracked. That's what's happening. Also notice that down here in the bottom, there are two unpushed commits. So why? Because we haven't connected it to GitHub in any way. Once we add it to source control, remember that picture that we had before, we're actually keeping track of things locally on our system now. There's no connection to GitHub at this point, right? We have to connect it through the origin remote, okay? So to do this, I go to Team Explorer, and again, you can activate Team Explorer by going to View, Team Explorer. You can do it that way too. I want to go to the home icon up here. This is important. Okay, and if I go to sync, right, for the first time, and I'm assuming that your settings have been already done, like we talked about last day. If I go to sync for the first time, it's going to give me to this screen if your GitHub extension is added properly. And then I'm going to click Publish to GitHub. Okay, now let me talk about this a little bit. Sometimes what happens is your installation might be broken, right? So this may not work properly, and you have to revert back to other means of doing the same thing. And I'm going to give you some other ways of doing it today. Okay. There's also this one, push to remote repository. So I could do this one. This creates the repository here remotely, or push to remote repository, which actually does something different. So there's two options. I showed you this option last week. I'm going to show you this option this week. So this option is with the basic installation of Visual Studio. Okay. So if I click this, it's going to actually say, hey, give me the URL. That's all it tells you. So it's almost like I've created my GitHub repository first, and I want to connect to it. Okay, so this is the second option. Let's do this one now. So as an option, I'll give you both ways of doing it. So again, I'm going to bring up GitHub. Here's GitHub for us. We're going to go to our Centennial College account. And this time, instead of creating it through Visual Studio, I'm going to connect it and create it through GitHub. So imagine you have your GitHub page open. Let's suppose this is your account, and I'm going to click New. When I click New, it's going to bring me to the new repository. So I can name the repository something that's reasonable. For example, something like COMP123 in the summer 2020 semester, and it's lesson 5, part 1. Same that I would name my, typically what we do is try and match the name of our repository with the name of the project. Typically. Sometimes not. You have a couple of options now. You can make it public or you can make it private. I'm going to make it public. Okay. If you made it private and if you share this with me, you'd have to actually, I wouldn't be able to access your GitHub repository at all. So please make sure that it's public, or if it's private, that later on you add me as a collaborator. And I'm talking about this in a sec. So let's go to here. What about this? Should I initialize this repository with a README file? The answer is no, don't do this. If you initialize the repository with a README file, it's going to create a commit. And guess what? There's going to be one commit up online and 2 commits locally. And your repository will not allow you to take new commits until you somehow merge these two things together. So please do not add an initial README file. Please do not do that. Also, do not add a gitignore file or a license. Please don't do those things right now. You can always do them later. We can always add a license file later on. Okay, but for now, just keep it public. It's easier this way, and then just click Create Repository. In fact, there's really nothing to touch. I just moved it from private to public, and then Create Repository. Once I do this, it's going to create this empty repository for me with steering instructions. Okay, so notice that I have a link. I need this link, and I have these steering instructions. If I want to do things with command line, if I wanted to push an existing repository, or I want to import code from another repository, there's a way of doing that. Okay. Here, I only want this link though, because that is what Visual Studio is asking for. Notice Visual Studio, if I go back to that, it says I need a link for the empty Git repo, right? Which is what this is. So I need to take this link here. I get this link as soon as I create my repository, and I can copy it here like this by clicking this button, going back to here, and then pasting it in here. Once I've got this and I click Publish, if everything goes well, we should be able to connect to our repository. Let's try this. So Publish. Now, what if things don't go well? And sometimes they just don't, right? Because Visual Studio is taking care of the baseline commands for you on the back end. That's why. So there are other tools you can use other than Visual Studio that will allow you to manage your Git and GitHub repositories. Okay, so notice that this is taking all kinds of time, right? But eventually it gets done, and it even gives you the repository here that's in line, right? Let's check and see now that it's done. It took me a few seconds, almost a minute, to make this done. And if I go here to my repository now, here it is. Notice that I need to refresh to see it. It's a web page, right? So if I refresh it, you should see something that looks like this. And it says I've got 2 commits. Here's my commits. Both of them have been done by Microsoft, right? Add project files and add my .gitignore and git attributes. These are 2 little files that tell GitHub what to ignore from my repository, because Microsoft Visual Studio creates a lot of little garbage files and a lot of stuff that's in the background that you don't need to push to GitHub. Okay, so that is what is being done here with this gitignore file and the git attributes. Okay, so let's just leave that alone. And let's get back to Visual Studio. So here we are in Visual Studio. So I wanted to show you this because this is an alternate path. Instead of clicking on the Git extension, we can do it the other way. All right, and sometimes we have to do it the other way because let's suppose you have created your Git repository first or whatever, we can connect to it this way. Okay, or if you somehow aren't able to make changes to your Visual Studio and you can't use the extension, the GitHub extension, so somehow you can't use this, it's preventing you, there's some kind of administrative issue, or it doesn't allow you to even add this in because you're not an administrator, who cares? Visual Studio comes with a built-in version that I showed you right here. Okay? Great. So I've got this. This is like the baseline. Notice it says 0 references. When I start using Git and GitHub, it tells me if I've got any references or if I'm even using this thing. All right, so back to my solution. I have a very empty solution happening right here. And I want to make some additional details. In fact, I want to start off, and I also talked about the advantage and disadvantage of using inheritance. I want to start off with those things we talked about. Remember, I talked about this idea of making a vector class, and a vector class having an X and Y coordinate. By the way, there's different kinds of things we can do in Visual Studio and C#. We can also create something called a struct. Do you guys know what a struct is? Were you guys told what a struct is compared to a class? I'm looking at the participants panel now. If you know, put a check mark. If you don't know, put an X or a no. All right? It's important you tell me, because if you don't know, I can get a sense of who knows and who doesn't know. Again, so I'm asking, do you know what a struct is? Okay, I'm getting some X's. I'm getting some stuff in chat. Please, instead of doing a chat, please let me know. I'm looking at the participants panel here. I can get a picture of who knows and who doesn't know. So it looks like a couple of people know, but there's more people that don't know. Okay, so that means I have to tell you about structs a little bit, or maybe remind you. I'm just gonna clear everything for now. Okay. So there's a difference. Classes and structs are very similar. All right. I'm going to make a struct, and it's going to be called a vector2D. So we're going to kind of right-click here. And follow me here to add a new struct. I'm going to add a new, right? And by the way, let's go to new item and let's see if that's even a thing. All right. So you can see that I have class. I can use an interface. We'll talk about interfaces later on next week. And if I scroll down, you can see that there is no struct necessarily here, all right, in the C# structure, right? So there's other things we can add, but none of that, no struct. And by the way, for now, what I'm going to do is in another minute or so, I'm going to lock the participation, so you go right into your, we're going to go into the waiting room after this. So we can use the same class, right? Here's the class, and I'm going to lock it now. I just was waiting for that to happen. I'm just going to enable the waiting room. All right, there we go. So let's call this vector2D. All right, so we're going to go down in here and just call this vector2D. Now remember, we talked about what a vector is. Okay, 2D instead of 3D. So I'm going to click add. It's going to make this a class, but I don't have to make it a class. I can make it a struct. Okay, here's a struct. So a struct is like a class, except a class by default is a reference type, and in C#, a struct is a value type. Okay, so that's the difference, the big difference in C#. In C++, it's different. They're the exact same in C++. The only difference is that a struct is public and a class is private by default. Okay, so all data members private. A struct, all data members public. Here it's the same, except that a struct is just a value type. So there's things you can't do with a struct, as an example, in C# that you can do in C++. Let's go in here. So for a struct, think about this as me defining a new data type. I want to make a new data type. It's a very simple data type, And conventions for the struct, by the way, a struct can have methods and it can have other things too, constructor. But here we're not going to do that. We're going to make a public float as an example, and we're going to call it x. And we're going to also make a public float, and we're going to call it y. So you can see that my new data type, which is vector2d, is going to have two floats, x and y, okay? And they're public, they're direct access. So this is where it's not a class, okay? I'm going to use this though, and I'm going to compose my transform from this vector2d. Okay, so we're going to talk about this. So, and I'm going to make another struct for now, or maybe we'll make another class from the from this struct. So here's the first thing. So we made a struct. It's called vector2d. Doesn't really do anything right now. And if I was going to add other properties to this vector2d struct, as an example, if I wanted to add things like calculations, dot product, and a bunch of other mathematical stuff, then I would extend this. And then as I extend more and more options in something like a struct, it's almost like I can convert it into a class. And the class conversion is very simple. I just change this word from struct to class. Done. All right? But things change in the background in terms of memory management and in terms of the way structs are being used. For now, though, convention says that if I'm only making a little data type that has x and y coordinates, and that's it. Struct might be the right way to go. Okay, so this is my vector2d, and guess what? We added a new thing to our project. Let's add it to GitHub. Team. I'm going to go to changes. Notice that I added a new vector2d, which is added. I'm going to go here to the message and say added vector2d struct. Okay, pretty simple. Commit all, and when I do this, it tells me I have to save. And this, now I've made a new commit, but this commit is a local. I haven't pushed this things to GitHub. Remember, there's two connections. One that's local, your local machine, and then there is your GitHub cloud, right? And I want to connect to the GitHub cloud through my my origin remote, and I'm going to do that in a second. I'm going to go back to home. I'm going to go to sync, and this time it gives me an option to push. And when I push, it's going to push my commit, the new thing I just made. Remember what a commit is. It is I'm only taking a snapshot of my files the way they are at that particular moment in time, and I'm pushing it on, right? So if I go to GitHub now, here's GitHub, and if I refresh in the commit section, you can see now that I have this. I added my vector2d struct. So, and each commit has a special commit number, and these commit numbers are unique, right? So, as an example, if I go to code now, you can see that in my folder for my project, right, I have my vector2d. So you can see that. So that's all it shows me. Great, fantastic. Not really that exciting, but it's there. The other thing I want to show you is if I go to the commits online, and if I actually click on a previous commit, this one, not this one, this one, what it's going to do is show me things that were added in the previous commit. But what you can also do, and if you notice here, this is a copy. I can copy the number, right? I can browse the repository with this link right here at the point in history. So I can go back, and now if I look at the repository and I go in there, you can see now that there is no vector2d. This is what happened before. This is what I had before. So why is this great? It's great because I can always look back and say, okay, before I did this commit, before I added a vector2d, this is what my stuff looked like. Okay, so you can always go back, and that's a beautiful thing about GitHub, right? And Git in general. If I didn't have this, then there's no way of looking back. I have no history of what I've done with my application development, which is a bad thing, right? So in real world, we kind of keep track of all our development history, and we can do that. We also know who did it, who added stuff, who broke things. There's a bunch of things. All right, but typically, it's used for those three things that I talked about before: version control, is definitely one of them. Backup and collaboration, because I can share my stuff with you just like I'm doing right now. Okay. Let's go back to this. So I got a vector 2D. It's a struct. It's like a class, but it's like a little data type that I've made, a custom data type. And what I want to do now, I'm going to go back to my solution folder here. In my solution, and I want to make another thing called a transform. Let's do that. So right click. I'm going to add a new class this time around. Here's a class. And we'll call this the transform class. All right, transform. Think about this. I want to transform or translate, if you will, my vector 2D. All right, it's just x and y coordinates. Think of it that way. So it's called transform. By default, it's a class. I could make it a struct here. I'm going to keep it as a class for a bit, and we'll talk about. It could also be a struct though, because I'm not going to do much with it. But I'm going to show you how you can mix and match. So here, what I can do is I can say that a transform has 3 vector 2Ds, right? 3 vector 2Ds. The first vector 2D, right, is in the position. So notice position, right? It by default went to private. I'm going to make this public, right? And let's make position capital P for now, because our position is public. And notice again, if I was to bring up my vector 2D, x and y are lowercase for a struct, but in a class, this vector 2D would be uppercase. So if I was going to make this into a struct, I would put this back down to lowercase. And I also want to make my position a property, so I can use get set, okay, by default. Or I can do it the short way by using a shortcut key. So prop, that's one way of doing it, right? And I can press tab, and then I can just say it is a vector 2D type, and my next property is going to be called rotation. Okay? So there we have position and rotation. We can rotate an object, let's say in 2D, if we're going to do that. Okay? Again, we're just imagining an object that's somehow displayed in a 2D map, x and y coordinates. We can move its position somewhere else, right? The position is an x and y coordinate, and the rotation is actually how I'm rotating it. I'm rotating it across the x-axis. If I'm rotating it across the y-axis, you know, that kind of stuff. Okay? And we have one more, prop, and we can say that it is also a vector 2D. And this vector 2D prop is going to be scale. So the scale, this scale property means I can scale it across the x-axis, or I can scale it across the y-axis. That's what this is. So I've got these 3 little properties. So properties. Now what happens if I converted this class into a struct? Can I still have properties? Let's take a look. What if I just did struct? Does it allow me to have properties as a struct? Absolutely. All the same. Okay, so nothing different between one thing and the other thing. The only difference is if I was going to make this a struct, by convention, I'd make these a lowercase p. That's what I would normally do. And I would get rid of this, because they would just be accessing members directly. So that's what I would do. So get rid of this. I'm just showing you that they're virtually identical. Just bear with me while I convert. So I'm just converting back to what it would look like if it was a struct. Okay, so struct, just a data type, a new data type that I'm making. And I would just convert these into lower p. Okay? Interesting. So transform, struct, right? Same as a kind of a vector 2, but a transform is a struct of vector 2Ds. So now it's a more complex data type, because it's got a data type of data types. Yeah? Little different than what we're used to. One more thing. So we have a transform, but I could have something else. I could also have some kind of rigid body if I was going to move an object around. And just to give you a sense of what I'm doing here, right, as an example, I'm just going to use a tool so I can demonstrate it with you. All right, not because I want you to do the tool or anything like that, but let's suppose that we're doing it. Okay, so just bear with me, observe, and then we'll go from there. So I'm going to use this tool called Blender. It's a free tool that you can download from blender.org. I'm going to kind of go there in a second. So if you really wanted to get to this tool later on, and I'm just going to talk about this right now, but you can go to, if I was trying to download Blender, Blender is a free tool. If you go to blender.org, right, you can download it. It is a 3D tool that you can use to develop all kinds of stuff, 3D models, animations, all kinds of things like that you want to do. Here, I don't expect that any of you are going to use this. I'm just showing you this is where I would get it from. If you wanted to follow along, you can certainly download the tool. I'm not going to show you how to use it though. This is just for demo purposes. All right, so cool. I've got Blender loaded. Here's Blender, and Blender, you can see it's here in 3D. I want to convert this so that it looks like 2D for now, so we can understand what I'm trying to do. All right, so again, this is just for you to watch. It's not for you really to do anything, right? As an example, so that way you're not confused. I don't want to confuse you. That's definitely not what I want to do. All right. So one thing that we can do is I can go into kind of a 2D mode in Blender. That's what it looks like. So you can see I've got a grid, and you can see I've got this square object as an example. And what I can do in Blender is I can just move this tool around. So I can kind of move the object around in 2D space, right, as an example. So I can do this because I can move, now because Blender's 3D, I can move in X, Y, and Z. It's like it has a couple things. Take a look at this: location, rotation, and scale, right? Those three things. So I'm just explaining how the class that I'm making here in our tool. So if I go to X is at 0, 0. Think about the 0, 0 point as the middle point of the entire world here, right? And if I want to move in meters, let's say to 1, it'll just jump over here to the right. So 1 to the right, X positive is to the right, X negative, right, just like in math, would be to the left, right? And then Y positive would be up, Y negative would be down. All right, so if I said negative, negative 1, you see that it's down in this lower quadrant because that's how it would be. Okay, so just simple stuff. Rotation's interesting. Here, really, we're rotating across the z-axis. So if I rotate it by like 30 degrees, you can see that it would rotate across the z-axis. I don't have a z in our example, but don't worry about it. And let me just undo all those changes, put it back into the origin. Here's the origin. And then for scale, what I can do is I can scale it across the x-axis or across the y-axis or both. So if I said, well, I want my scale on the x-axis to be twice as big, you can see now that the scale would make this object twice as big. And if I did the same thing on the y-axis, it would also be twice as big. Or I can just reduce it on one axis. And you can do whatever kind of shape you want. Okay, so that's kind of the way it works. So that's Blender. I'm not going to do too much here more in Blender. I just wanted to explain what the transform does. Okay, so let's just go back to Visual Studio. So here we are. Okay, clear? Any questions around what I just showed you? I'm just going to look over here on the side. So again, all I'm doing is I am mimicking what it's like in the real world with some code. And that's what we do normally when we start off stuff. Okay. So here's my transform. Here's my Vector 2D. You know what? This is a great time to put this up on GitHub because we've added another struct, a transform struct. So I'm going to go to Team Explorer, and I'm going to go to Home, and I'm going to go to Changes, and you can see that I've added a transform. I'm going to add this thing. I'm going to say added transform struct, commit, and I'm going to go Home, Sync, and Push. And it pushes up to GitHub. By the way, I just wanted to let you know this. My underlying reason for doing these little commits and for doing these things is to show you again how to use GitHub. Because we're going to be using GitHub going forward, I want you to be comfortable using this thing. And I also want to talk about different things like structs and classes, and for you to know the difference. So again, difference between a class and a struct for you guys is class is private by default, and it's a reference type, and a struct is a value type. Okay, that's really, really important. Okay, so pass by value, pass by reference. Whenever I kind of pass something by reference, I don't make a copy. I point to it in memory, but as a value type, I actually create a copy of it. And that's the difference between one and the other. Okay, cool. So that is my transform. Fantastic. I'm going to go back to my solution. Now, finally, I'm going to make my first class. And we talked about this before. I'm going to make a game object, Superclass. So I'm going to right-click here, and I'm going to add. Oops. I'm going to not do that. I'm going to right-click and add a new class. I'm going to use the quick hit menu here. So I'm going to click here, class. And under class, I'm going to call this the game object Superclass. Game object. Okay, game object. Here we go. Add. And now here's where we get more complex. Game object. Under game object, I want to have a transform, right? And my transform is going to be a, I'm going to have a transform property, right? So I'm going to say that prop transform. Okay, so now I'm going to use the quick hit property, get set. The type, the name is going to be also transform. Hear me out for a second, right? So transform should be capital T, right? Because it's a property. Oh man, how can I do this? I can make the name of my class transform and the name of my property transform. Well, of course I can, because it's not transform as the class if I do this. It's game objects transform. So it's okay to do. Also, when we start planning classes, like I talked about last day, we want to do something like our private instance members or fields go here. Our public properties go here. Our constructors go here. Our private methods go here, and our public methods go here. Now I have a transform. This is a property. I'm just going to move it up to public properties right here. So there's our transform. So that means all game objects has a transform. Every game object I make. Okay. For now, I'm going to leave the for this particular this game object, right? I'm going to make a constructor that is just, I'm going to use the default constructor. That's all I'm going to do, just the default constructor. So let's think about all this other thing. So I have so all game objects, let's say in this phantom game I'm making, let's just say, all right, has rotation, position, rotation, and scale. All game objects, right? They have that. They also might want to have a name. I want to name the game object. So let's add that in as a property. So all game objects should have a name, right? As an example, that makes sense. So let's make that, but let's use the other way of doing properties. So I would say we'll make a private name. So m_name. I said that we should probably name any kind of private member with an m underscore. M is member, underscore is private. Private member, right? And the type would be a string. So private string name, that's what this is, okay? And then this is a long form way of making a property. Long form way is you'd say public, right? The name, or the type, which would be a string. Then proper name that it's going to be showing for other users outside of this class. Name, capital N. And then curly braces, right? Which is the container. And then I would have a getter as well as a setter area. We call them getters and setters, but remember what they are. Set, mutator, get, accessor. I know I'm repeating myself, but I'm doing it for learning. Then my getter, by default, I'm going to return m_name. And by the way, what I could do, like I said before, I don't like the way that it's doing this. That's just Resharper. What I could also do is be explicit. Right now, implicitly, it's using the this keyword, right? This.m_name, right? And I could also do explicitly say that this m_name is equal to value. Did you guys learn the this keyword and what it means? Can anyone tell me what that is? What is the this keyword? Yes, I'm seeing some check marks. That's good. All right. And please also put the X if you don't remember, please. It's going to help me identify if I have to show you this again, or if you all know, then I'll just move on. Okay, I'm seeing check marks. I don't see anything that is really an X, so I think we're good. Moving on, so I'm just going to just clear those. So that means, so this is, it talks about the context of the class itself. So it's like this class's mname. Okay, return this class's name. Okay, return this class, or add, kind of assign a value to this class's private member name. All right, that's what this means. All right. Sometimes we need to use this because if we have the same name for different variables, this makes it very clear. Okay, so we don't need to use this. It's implicitly used anyway. Whether we use this or not, it's still going to work because implicitly, when I make a property, it uses the class's private member. Okay, so we got this couple of properties here: the name of the game object and the transform. So those two things that we have. Okay, and maybe in my constructor function, by default, one thing that the game object's always going to ask you to do is you need to add a name. You have to name this game object. Okay, so let's do that. I'm just making the scenario up, by the way, guys. I'm not following any kind of method or whatever. So follow with me here. So again, I would make a public game object, right? And inside this, I would pass in a string name. Okay, here it is, and the name would be this dot name. I can say this dot name is equal to name, or that makes it clear, right? Because it's like this dot name means this name, this property, and name here, if I was going to make it the same kind of uppercase character, means the parameter name. So this is where this keyword makes real sense. In this case, though, we would never name a parameter like this. Typically, we might call it name, like lowercase name, and therefore, we could remove some of this, confusion. Okay, so that's the one thing that I'm going to ask that all game objects do is when we construct a game object, we're going to have a name that we have to call them. Yay, we've added a game object. It doesn't do anything, but we've added it. Okay, and the game object is going to be added as a superclass. All right. So again, great place to put it up on GitHub. I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to added game object class, right? Commit all, home, right? Sync, and push. I'm pushing them every single time. I don't have to do this. I can wait for a bunch of commits and then push everything later if I want to. But here I've just pushed, one commit after the other. And we see what we're doing. We're actually building more complex structures as we go. First I built a vector 2D, then I built a transform, then I built the game object from those objects. So here's an example of, right now, what we have is, we don't have any inheritance. All we have here is composition. I'm making up my game object by using custom data types that I've created. All right, so there's no inheritance, none at all. Okay, hopefully that makes sense for you. So now that I've done this and I've got my transform, let's test my game object. So I'm going to go to my solution. I'm going to go to my program. And program is a great place. This is the entry point of my application, like we said before. I'm going to test it. So I'm going to say that I want to do a couple things. I want to do a console.readline, right? Because that will just hold the console back. So I'm listening for a key. Listen for any key, right? And here I'm also going to do I'm going to test my things, make a new game object. I'm going to say game object. We'll call this thing player. That's the player game object, and that's equal to a new game object, right? And you can see now it requires a name. I'm going to call this thing player. Okay, so it's the player game object. Yeah, so far so good. And what I want to do with the player, the game object doesn't really do anything, but let's suppose that I want to set the player's position the default position is 0, 0, but I want to set the player's position on my 2D map, let's say to 100, 100. Okay, so I can say that player.transform.position, right, is equal to a new vector2 object, right? And you can see that my vector2 object, when I do this, it has x and y coordinates, and it goes, and then I have a bit of an error. Okay, let's take a look at here what I've got, right? So a new vector2d object, and if I go to this thing here, it says introduce variable, introduce field. If I do introduce variable, it says that the variable player transform is equal to player.transform, and what I'm doing actually is saying that the player.transform.position is equal to this new vector2d object. Okay, let me just undo that change. So that's kind of what I want to do here. Player.transform, right, is equal to this new thing. Well, why am I having this error? And if you hover over, it says cannot modify the return value of game object transform because it is not a variable. Okay? Property transform access returns temporary value, cannot modify struct member when access struct is not classified as a variable. Think about what that's saying there, right? So now let's do a semantic change and go back to vector2d just for a second. All right. I remember I talked about struct being the difference between a struct and a class is just value. If I change this to a class, just for a second, and if I go back to transform and change this to a class, all right, just for a second. So class, class, and then I go back to my program. Suddenly, no errors. Why? Because remember what a difference in a struct and a class is. A struct, I have to copy. It's a copy. It's a value type. And where a class is a reference type. So what I've actually done is when I go in here to my vector2d object here, right? X and Y coordinates by default become zeros, right? So that's what happens when I instantiate an object of type vector2d, right? Whether or not I have a constructor, the default constructor, as an example, these variables here in C# are initialized to 0 by default. Okay. Same thing with the transform. Because I have 3 vector2s, right? Each of these objects are initialized as a as 0. So the position vector, right, as an example, is initialized as 0, 0, right? And when I go back down to the game object, you can see as soon as I do this, right, and I construct a game object, my transform by default, without kind of constructing it at all, is automatically a instantiated with 0, 0. Okay, so we're going to leave it like this for a second just to make it simple, and we'll go back and fix them at another time. Okay, make them back into structs. So bear with me while we go. Okay, so going back to my program, that would be an issue. Player.transform.position. Notice that it says transform with a capital T, right? Because transform is the way we named it here in my game object. We call the game object transform with the capital T. Here's a breaking change. Let's suppose I'm messing with a class and I change this to a T. Transform with a lowercase t now. And if I save it, if I go back to my program, you can see now instantly I have a problem. And that could be an example of a breaking change. Let's make this back to lowercase t. So program.transform.position. Now this is interesting because what I'm doing is I'm saying, which thing am I modifying? Am I modifying my transform? Yes. But I'm modifying only one part of my transform, my position object. And I'm making it a new vector2d. But what is a vector2d? X and Y coordinates. Wouldn't it be nice if I can specify what the X and Y coordinates are? Because right now I can't. It's by default zeros. I mean, I could do something like player.transform.position.x is equal to 10. Right? I could do that. Right? Because now that I've made it a brand new vector2d object, I mean, I could do that and specify this directly, right? Because that's how the chain works. Player is the game object. Transform is the transform that's part of the game object. Position is the vector2d that's part of transform. And x is the float that's part of the vector2d, right? So that's how it goes in this dot accessor method chain. Okay, that's how it works. So pretty simple. So I could do this, but it would be nice. It'd be nice also if when I do this vector2d, I can take either x and y coordinates or put nothing like this. So in order for me to do that, I can go back to my vector2d, right, and create a constructor function for it. So I can say public vector2d, and now in my constructor function, I can specify default values. I can say that a float x, right, is equal to 0.0f, f for float, and a y, which is also a float, a float y is equal to 0.0f. So you notice now what I've got is I've got these default values in my constructor. So again, let's just make this clear. I've got some, in this case, public instance variables. Take a look at this, right? In a struct, this is okay, right? In a class, this is not okay. You should have a private instance member and a public property. We'll come back to this in a bit, all right? So I can say that x then is equal to x. That's bad, right? And it's confused. It says, like, which x are you talking about? I mean, this dot x is equal to x, and this dot y is equal to y, right? I need to specify here. This is where the this keyword is super important, because it basically allows me to be very explicit with the compiler, so that C#, the Visual Studio compiler, goes through and understands what I want. Otherwise, it wouldn't know, right? So this is constructor, right? And I don't have any methods yet. So a couple things there. Nice. So far so good, right? But now that I did that, because I made a change to my vector2d class that takes x and y, notice that this still works, because by default, if I hover over this, I can take optional x and y values. Optional. That's what the square brackets mean. And if I was going to document this thing as an example, and I can do that by using the triple forward slash, so triple forward slash 123, it tells you that these parameters, I got two parameters, x and y, right? And they're optional, right? Parameter name extra. So I can say that this constructor takes x and y as optional values. Okay? Let's say column parameters. Okay, that's what it is. Optional x and y as optional parameters. And if I was to now hover over my x and y, my vector2d, you can see that that's the instructions I'm going to get when I hover over. Whatever I put here in the comments, this triple forward slash example, I actually get to see them when I hover over. So if you're going to make your class and give it to somebody else to use, you can see here that they're going to get instructions. Okay, that's how it goes. All right, so this is cool, vector2d. Let's check this. I want to print out the vector2d. That's what I want to do. But man, vector2d doesn't have a toString method at all, right? Wouldn't it be nice if I can format my vector2d method to show, you know, my toString value? Well, let's do that. So let's make a new here in my class. Let's make a new toString. So I'll say that toString, right? And it's going to be public override. I'm overriding the natural toString method that comes with the object super duper class, the super object class. That's where toString comes from. All classes have toString, right? And I don't want to return something. I want to create some kind of output string like we did before. Output string, right? And let's say that's going to we're going to start off as this, right? And I want to build my string up. Or I can just make it here. I can say that $ curly brace. You know, we can start going like this. Okay, so x as an example here, comma, and then y. So it's going to show a very nice way of showing my coordinate. That's what I want this to show. I could also make this happen in one line by just returning it here. I'm just making it so that it's in 2 lines. So you can see this output string. Okay, there we go. And let's get rid of the spaces. So what this does, it says, okay, I want to make a new temporary value variable called output string. Output string is of type of string, and it's going to have this interesting way where I'm going to inject the value of x and y inside here and show it as an example as a string. Okay, so a 2-string method. And again, if I want to document this, // this method returns the value of the x and y components in with the format x, y, okay, as a string. Okay, so that's kind of what it does. I'm just formatting as we go. And because this is a method, right, then we put it in the methods section. I would just say public methods, right? So here we go. We have public instance variables. This is bad. Constructor, there's only one. Public methods, only one. If I go back down to our program now, because I've modified my vector2d, I could do something that looks like this. Console.writeLine. And I want to output my player.transform.position, right? .toString. I can do that. And I can do that for all of them, by the way. So I want to just see my player position. Let's run this thing and see if it works at all, or if I get an error. So run. And I'm going to get an error, right? So it says system.null reference exception, object reference not sent to an instance of an object. So can anyone tell me what happened? I mean, I did everything right, didn't I? Didn't I create my new vector2d object, right? What part did I miss? What part did I forget to do first? And is there something that I could have done different here than the way I've done it here? Anyone know? Can anyone figure out what I did wrong? I made a player, .transform, .position, Remember, here's some hints. Here's vector2d. I have to make a new vector2d. Here's transform, few things that I've included. And I just made a public property for transform right here. But remember what this transform is. This transform is not just a regular struct, right? My transform is a class, right? And what do I have to do with objects of a class to use them? I need to instantiate them. So if I'm going to make transform a class, somewhere in here, right, before I do anything else, I need to instantiate a transform. So let's make a new private method in my GameObject superclass. And my new private method is going to be called initialize. So private, we're going to call it initialize. Now there's a couple ways to do this. It's a private method. So typically what we do is m underscore and the name of the method. In this case, the name of the method is going to be called initialize, right? And my initialize method, it's going to return void. It's not going to return anything. It's going to be made for me to initialize some variables. And I'm going to call it typically inside of my constructor function. So my constructor function is going to call initialize. It's private because the world doesn't need to know how I'm initializing my variables. Okay? And what I'm going to do is I'm going to say that transform is equal to a new transform. I need to do this. If I don't do this, then I don't have any memory set aside for this particular construct, right? I don't have these things. And in fact, transform itself, when it's initialized, when it's called, should initialize those three vector2d objects. So this is right, but here in my transform class, I should probably initialize these two, right? So again, I have some public instance variables, which are bad. Okay, I can fix this by making them public properties. Okay, but just bear with me while I do this. And then I need to make a constructor, right? And we can call the constructor transform. But this is going to be the empty constructor. This is going to be the default constructor. However, what I'm going to do with this constructor is also I'm going to have a private methods area, and I'm going to make a new private method which is called initialize. Private m_initialize. It's also going to return void. And I'm doing this for a reason, guys. And in my initialize function, it's going to be called by the transform m_initialize. So you can see that when the transform is created, it calls the initialize method, which is down here. Okay, and the initialize method does exactly what it says. Position is equal to a new vector 2D object, right? And then rotation is also equal to a vector 2D object, as well as scale is equal to a new vector 2D object. So there you can see I've made, I've initialized everything I need to privately for all the structures of my transform. If I go back to my game object now, you can see that when I do this, transform, it'll cascade and it'll do its job. Transform does its job, game object does its job, and when I go back to the program now, and if I do this, I could do this, but it's been done for me. I don't have to do this anymore here, right? Let me show you. If I just comment this out now, right? I don't have to make a vector 2D. I should get 0, 0 now when I print this out. Let's take a look. So if I run this code, if everything went well, right, then I should get 0, 0, just like this. You see? Clear as mud? I know some of you might be confused as to what I did. Remember, there's no inheritance here. This is strictly, I'm taking a game object and I'm making a class a little bit more complex than you're used to so that your mind can't figure things out. Because a lot of times what we do in class, guys, is we make very simple structures where your mind can figure it out automatically, 2 seconds, right? Here I'm making it so your mind can't figure it out. You have to map it out in your head a little bit more. So that way one thing impacts another thing, all right? Because in the real world, it kind of works like that. You have different things happening, right? So I'm making complexity for you. Remember that the vector 2D is x and y. By default, it gets initialized with 0, 0, so this is okay, right? And when I have my transform, I have a toString method. I need to make another customized toString method. It would be nice if I want to print out my entire transform. I want to print out position, rotation, and scale, and have its own toString method. So let's go back on here and go toString, and notice it does this. And what I want to do is do the same thing. So I want to do an output string. Okay, I want to start off in this case like this time. And what I want to do here is I want to say that output string, I'm going to make it 3 lines, right? So the first part of the line for output string is going to equal to the position. All right, so my position is going to equal to something. And I'm still going to make this a $sign here for a second. Bear with me. So curly brace, and I want to do the position vector in here. So I want to call the position vector. I could do it manually, or because the position vector already has a toString method, right? I can just concatenate. Isn't that right? Because toString returns that nice little X and Y pattern. Position is something that I'm going to output just for the position. And what I also want to do then is add a \n character for new line. \n is a special character that the string uses to go to the next line. Okay? So let's copy this a couple of times, and we'll get rid of the \n the third time. So we don't need a \n character here, right? because I'm going to get that from the, actually we'll leave it in. That's not a bad idea to leave in. So position, rotation, and scale. I can just change these to rotation and scale. And now I want to output my output string. Output string. Okay, pretty simple. So we have another toString method. This toString method is for the transform, and it's going to use the toString method from the vector2d object in here, composition. Okay, this is what this does. And again, I can use the triple forward slash to say that this method formats the transform to show each of its components. So that's position, rotation, and scale in a string format. Actually, that's good enough, because that's all we're saying. Okay, so this does everything else. Nice. And once we get to this, as an example, if I go back to my program, instead of me doing my player.transform.position.toString, I can just say, let's back it up. I can go player.transform.toString. Okay, so what this does, it takes the entire transform and outputs it. Let's try this out and see what it looks like. Wait, what? Huh? What happened? I don't understand. Well, I understand. I did a couple things wrong, is what I did. So instead of \n, I used /n, right? And I did equal, 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 and what I meant to do is plus equal. Which means I'm going to concatenate, I'm going to add to the output string, which is originally nothing, the position, rotation, and scale. Let's try that again. Yes, and that's what I was looking for. Now, if I want to format this nicer, because scale is shorter than position, rotation, I can change it here. I can just go to add a few spaces here so it's all nicely aligned. And if I do that again, you can see that I'm going to get position, rotation, and scale. They're all zeros. Are you with me? Check marks, please, if you're with me. Some people, yay, good, good, good. All right, so I mean, pretty simple stuff right now, right? Okay, so far so good. All we've done is review a little bit of transform. Thank you for that, guys. I'll clear that for you. We just reviewed how to make a more complex class. That's all I've done here with you guys. And this is what we're going to use for next day as well. Okay, that's why I spent all this time doing this. And also reviewing for you guys how all this works. Okay? Now, finally, let's go and do some polymorphism and some inheritance. Okay? So first of all, we've actually been doing polymorphism without using the virtual keyword in some ways, right? What I'm actually doing is I'm going, wait, you know what? I'm changing the transform. I'm overriding the toString method. Whenever I override anything, I'm using polymorphism right there. Why? Because I'm taking the original method and I'm changing it so that it makes sense for us, for that particular class. So this is cool. I've made a player, which is a game object of type player. And then what I can do here is I can go through and I can say, hey, I want a console write line. Right? I want a console write line my player.name, right? And if I was to kind of show this and start, you can see that I'm going to get player, and then here's the position. Nice, nice. But it'd be really nice, super nice, if I also overrode my toString method from my player, and that did all of this for me, right? Let's do that. So game object. I've got my public method. I'm going to use the toString method. You can see that I've overridden the toString method a bunch of different ways. And again, I'm going to start off with an output string. So string, output string. Right? Let's make that equal to this. Okay? And for now, my player, as an example, right? We're going to return output string, just so I don't forget. My player only has a name property. So for now, what I'm going to say is we're going to say that output string, right? I can say is equal to name. And, you know, to be really nice, to make sure that it looks nice and whatever, we can remember how many spaces we use in the transform. So NAME, and then that's 4, right? There's 4 characters here, 5, 6, 7, 8, colon, all right? So we have 1, 2, 3, 4, 5, 6, 7, 8 characters and a colon just to keep things straight. So let's try this out. So 1, 2, 3, 4, 5, 6, 7, 8, and a colon, so name, right? And we also want to say that we want to include the name here because this is something that is part of the player. So we can say we want to have the name go here. Bear with me. We have to change this into a $sign to make that apparent, right? And then what we want to do at the end of the name is a \n for new line character. Okay, so output string is equal to name. Yay. And then what I want to say is I want the output string to equal to the transform dot toString. All right, so that would add the transform toString to this toString, right? And then output that whole thing. And I need to make this a plus equals, and same thing with this. Okay, so plus equals, output string is thing. And then what I can do is once I've got this little piece of code, I can go over to my program, and instead of doing all this mess, I can literally just go player.toString. And that would show me everything that I had before, plus the player's name, like this. Nice? \n, yes, thank you for that. Make sense? All right, so now that we've got this, let's make 2 more classes, right? Instead of me doing this game object as player, game object is really generic. And maybe my player is, you know, going to have certain characteristics where I can move them, and my enemy is going to have certain characteristics that I can do them. For example, my player might allow me to control the player. I can maybe get input for the player as an example, whereas my enemy is automated and might have AI and might do different things, right? So let's make you know, an enemy class and a player class, and we'll come back to this in a second. Okay, so again, so far we have a game object and we've done some changes, and this is a great time to put this up on GitHub because we've added the vector 2D, the transform, and the program, and we've outfitted the program for testing. We made the game object work kind of like the way we want, and so this is a great place to put up on GitHub. But what commit message am I going to put up? So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. You can see that I've changed everything, right? And I'll say some kind of commit message like, you know, updated class structures for project. Something generic, which is kind of what I did. I went from a struct to a class. I added 2 strings. I could have done more commits here. I didn't. I'm just going to do 1. Okay, so commit all, home, sync, and push. So you have all that stuff that I just talked about up online. Okay. I guess I'm pushing to GitHub a little bit more often right now. And now what I want to do is I want to add a player class and an enemy class. Okay, let's do that next. So I'm going to right click here. I'm going to add a new class. Let's make this the player class. Right? And let's automatically make the enemy class too. Why not? Add a class that is enemy. Both classes, player and enemy, are going to derive from the game object superclass. So let's go enemy extends game object, right? And it says, hey, we're missing some stuff, it's true. And if I click on this little light bulb, by the way, did anyone have a chance to go and download Resharper from JetBrains? I got one yes, I got a couple yeses. I highly recommend it, guys. It's going to make your life a lot easier. I talked about that last day, or last week. Make sure you get it, because then it does this for you. Otherwise, it doesn't look the same. All right, so if I click onto this and I go implement missing members, you can see that it generates my constructor. My constructor requires a name. That's the default thing that my constructor needs for the enemy. So for now, I'm just going to pass this colon to this. So the base constructor, remember, whenever we do inheritance, the base constructor must be satisfied. So because my base constructor of my game object takes a name, right, and there is no default value for the name, it must have a name, right? Therefore, I must, kind of satisfy my constructor here from my objects that are inside, all right, or the derived objects. All right, so here's the derived object. Do the same thing with the player. So player, and then I extend the game object superclass, right? There we go. You can see now that I've got both those are pretty much the exact same. They're identical. But let's suppose my enemy is able to shoot at the player, but my player in this game that we're making can't shoot back. Okay? It has different properties. And let's suppose also that my player has other things, that the enemy doesn't have. Well, we know a couple things, right? We know that because player and enemy both derive from my game object superclass, they both have a transform. By default, they both have a transform. All right? So let's go back first and let us add something different from my enemy. My enemy can fire bullets, okay, as an example. Let's just say. So let's structure things again. So what I would do is, it's a private instance variables out. Right? Public properties. God, I can't type today. So what happens with Father's Day? Father's Day, you have too much relaxation on the weekend and it messes you up. Constructor, right? As well as private methods and public methods. Okay, so all those. Let's do the same thing with our player. Just to be quicker, I'm just going to copy these things. Not because I don't want to. I am copying, but I'm just copying comments, guys. So if you're like, wait, Tom, you said if you copy anything it's bad. It is. But it's kind of templating here. I'm not really doing anything from a code perspective. Remember, comments don't really count from a compiler perspective at all. All right, so here I've got exactly the same thing. I got my player, but the difference between my enemy and my player, my enemy is going to have a firing method, and my player is going to have a shield. Okay, those are the two things that it's going to have. So two different things. All right, so let's say we have a public method for my enemy, which is fire bullet. So public fire, it's going to return void. So fire bullet. Okay, we can't really fire bullets here. Oop. But what we can do is we can console outline. So console.writeLine. Well, you can say that firing bullet. Okay. Okay, so that's firing bullet. And guess what? Our player is going to raise shields. So we have a public void raise shields method, and when it's triggered, it's going to what did I do wrong? Raise shields. Why is it giving me this thing? Unexpected token. That's weird. Am I outside the class? I am. Ha 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 ha. All this is outside the class, guys. Yeah. I'll be okay. So raise shields, we'll say console.WriteLine raising shields. Let's say the shields has some kind of value. All right, for now. So those are the two differences between a game object that's a player and the game object that's an enemy. Cool. We have two different things. Let's test it in our program. So instead of doing it this way, oh, here's something we can do also. We know that the player, as an example, is going to have a name player. So when I instantiate the player, I can automatically put the name in there. So instead of player taking on a string name that's player, I don't have to do this. I'm going to say that the name is player, right? I can just pass in the name right here because this is a constructor, right? So I don't have to take a player constructor. However, the enemy, maybe there's different kinds of enemies, right? Here's my enemy. And it's going to pass its name, whatever it is, to the to the base class. Okay. So that's something that's going to happen. So here now, instead of making my game object player, I don't have to do this anymore. I can simply say that player is equal to a new player, right? Player still has a toString function. This still works because player is a game object, right? So because it's a game object, it inherits this nice little toString method, right? Player does not have a toString method of its own, okay? Player is using the toString method that's built into the game object superclass. Enemy, right? Same thing. Let's go into program, and now what we're going to also say is we're going to make a green enemy and a red enemy. So enemy, we'll say green enemy is equal to a new enemy, where we're going to pass in the name green enemy. Okay. And we'll make another one, which is red enemy. Just to make it clear, we'll just put a space in there. There we go. Green enemy and red enemy. Yay. And we'll do a write line for the player, toString, sure, no problem. And we'll make the player raise shields. So player dot raise shields, right? And the enemy, we're going to say enemy. We'll do a console write line too. Let's do this. Test the enemy. And we'll do for the green enemy to show all this working. And we'll say that the green enemy dot fire bullet. And we'll also say that console write line. Here, let's do this one. Just to make it quick because we're going to run out of time soon. And we'll say that the red enemy also fire bullet. Okay. Now, I mean, again, this is very simple, but the idea here is that both the player and the green and red enemies, actually the player and the enemy class, right? They're specialized versions of the game object superclass. They're all game objects. All of them are game objects, but they're different versions of each other. Players can't fire. Enemies don't have shields. All right, that's so far what the difference is between enemies and player, right? There could be others, but I'm saying, but however, I could say that my player dot transform dot position, right, is equal to a new vector 2D object. I can just replace the vector that's already there with a new vector. Let's make that proper, 0. And let's do this also. I'll say that this enemy, so green enemy dot transform dot position, is equal to a new vector 2D object that is, let's say, 60 and 80. And let's suppose this enemy oh man, sure, that's going to start at the origin, because remember, by default this enemy here can have, if I don't specify a value, vector 2D is going to give me a 0, 0 by default. All right, and then let's go take it one more. Let's move these down below, right? So we can see that the transforms are different. The rotations are going to be the same because we haven't modified the rotation at all. We just changed the transform position. That's all we're done. Okay, so just taking away some of these spaces so that it's something you guys can all read. I'm just reordered some of the console write lines so that we can see them in order. Right? So let's see if it works. Okay, so and we can see that now we're going to get this. Nice? And you can see that all the stuff is different except for, what did we do wrong? Green enemy and red enemy. Oh, we did the wrong one. We didn't print out the right thing. My bad. Let's just did, that's a copy paste error. And you can see now that they have different values. So you can see that the position of this player has 100, 100. This position has 60, 80, and this one has 0, 0. These two are firing bullets. This one is raising shields. Again, this is more for you guys so that you understand how I'm composing my classes composition by adding a transform, and the transform is actually made up of vectors, right? As well as I'm inheriting, simple inheritance, where I'm inheriting from my game object into an enemy or a player class. Okay? If that makes any sense. All right, cool. This is okay. We're going to do one more thing here before we stop for the day, because I'm just reviewing some stuff. So what if, right, I have a fire bullet, right, but I want to make a different kind of enemy, a boss. So it's an enemy, but it's a specialized enemy, right? A boss enemy. Let's make one more, okay? And then we'll stop for the day. Right click. We'll add a new class. And the new class is going to be called we'll call it a boss, right? And let's make it enemy boss so we know what it is. Or a boss enemy. How about that? Because that's normally how we do it. Boss enemy. And the boss enemy, instead of it deriving from game object, is going to derive from enemy. So we're going to say it derives from enemy, and enemies require a name, right? But we're not going to do this here because it's a special type of enemy. This enemy's constructor is going to have, let's say boss, because we know it's a boss type enemy. And what we're going to do is it fires bullets, right? But I want the ability for me to override the bullet firing, so it fires fatter bullets than regular bullets. Okay? Well, I have a problem, right? And let me just talk about this for a second. Let's suppose that here are my private instance variables and my public properties that I haven't used. All I'm doing is I'm creating some templating for this stuff. Here's my constructor function. And then down in here, I'm going to have my private methods. Again, this is the way I'm structuring it. You might structure it different. And public methods, right? So public, private, blah, blah, blah. And one thing I want to do is I want to override the bullet fire method. Well, if I did that, or notice that my bullet fire method here, fire bullet, it's just a regular method. Can I do that? Can I just go something like public fire bullet? And then I can go void, right? And do one of these, and it gives me this really weird error. It says the boss enemy fire bullet hides inherited member enemy fire bullet. Use the new keyword if hiding was intended. Hiding was not intended. I don't want to hide it. I want to override it. So I could still do this, right? But proper polymorphism rule says I need to use virtual as a keyword. So going back to the enemy, I want this to be overwritten. I'm going to use virtual. So private virtual void, virtual, this keyword, allows me to override this thing. But now it says it hides in care the member, and fire bullet is never used. You know, what I want to do is I want to type in fire bullet, and notice as soon as I start typing, because I put the virtual keyword in there, it gives me this public override word. Now this is good. It says, hey, I'm going to override the fire bullet method of the base class, my base class being the enemy superclass, right? Just like I did with the toString method, right? And this time, instead of me console right-lighting, I can make a whole new implementation method, right, for how my fire bullet works. Okay, so again, going back into my enemy, you can see that I'm just doing a console right-line firing bullet. Well, now I'm going to fire a fat bullet, because it's going to be a big bullet, some kind of bomb or something like that. All right, that really impacts the player more, does more damage, you know, that kind of stuff. And we can talk about damage and all that kind of stuff in the next example next day on Wednesday. Okay, so again, I'm going to do a console dot right line, and we're going to say firing fat bullet. Make fat even fatter just by putting it in caps. How about that? All right. So yeah, both of them have fire bullet, but this one is different than the other ones, just like our toString method. So we must use a couple things. Whenever we want to override methods, just like you've learned before, we need to use the virtual keyword. And it goes right after the access modifier and right before the type that it returns. So public virtual void is an example, right? And this is what the game object superclass, the object super duper class, the one that's above all other objects, that's what it does. It uses the virtual keyword, so that way you can override the toString method. Okay? So again, my boss enemy overrides this by fire bullet. Everything else is the same as an enemy so far. We haven't really made a lot of specialization. We could also say that, and we will do this later on, we can make it so that, and we can configure the boss enemy so it has more points. Maybe it has armor, you know, all this other stuff that, you know, maybe my enemy doesn't have. Maybe my regular enemy, doesn't have that stuff. It doesn't have shields. But maybe my boss enemy has shields too, right? Because that's the way it is. So we'll talk about this next day when we get to configuring this stuff, okay? Again, these are all analogies. Okay, let's go back. So now that we have our boss enemy, I want to try this out. So I want to say something like, hey, let's make a boss enemy. So boss enemy, we'll call this boss enemy. It's only one of them, equal to a new boss enemy. I don't have to specify the name because just like the player, the boss enemy already says that it's the boss, right? And I want to say that the boss enemy fire bullet, it also has a fire bullet method, but this fire bullet method fires a fatter bullet than the regular bullet. And I also have a transform, boss enemy dot transform dot position. Let's make that equal to 200.0f and 200.0f, f for floating point number, right? And let's output that stuff, console.writeLine, right? And we'll console writeLine the boss enemies dot toString method. Okay, so all the stuff we've seen before. So everything else the same except for this. And this is a great way of testing all of our little classes. So if I run this thing now, we should see everything that I wanted to show you. So again, raising shields, the player, firing bullet, the green enemy, firing bullet, the red enemy, different positions. So you can see that each instance of the objects that we have different properties. And then when the boss fires a bullet, he fires a fat bullet as opposed to a regular bullet. They use the same method name, but does different things. Okay? Questions around this stuff? All right. Meanwhile, what I'm going to do is I'm going to put this up on GitHub. So I'm going to go to Team Explorer. Again, I'm going to go to Home, Changes. You can see here that I've added an enemy, a player, and a boss enemy. So I'll say added enemy, player, and boss enemy classes. That's all I really did. Commit all, home, sync, and push. Okay, so that kind of does pretty much everything we want. So, any questions at all about the polymorphism? And we tackled one part of polymorphism today, which was we can make a method that's different. But what I've done here for you guys and for me for next day is I set up a more complicated class structure so that way we can talk about it a little bit more. There's still quite a bit of things we can put in here as we're making our phantom, our virtual game, if you will. Actually, that sounds weird. More like a simulated game. We're not even making a game here. We're just making some structures. That's all we're doing, right, in a console app. But the idea here is that I want you guys to understand how things knit together. The difference between a inherited object, like for example inherited class, like how the enemy inherits from game object, and how the game object uses two other classes, vector2d and transform, to compose itself. That's what it does. And the fact that I had to instantiate something, I had to initialize. Think about this before I let you guys go for the day. How the vector2d object, right, how it didn't have to initialize because it has a default value for each of its objects, x and y, and they're just regular floats. However, the transform object had to have this initialize method that I put together. And what I did was I set aside memory, if you will, for each of the vector2 objects that make up its position, rotation, and scale. And the game object, furthermore, had to have initialized the transform, and I had to put memory aside for the transform itself. That I had to do differently, and I didn't have to do that before. Why? Because you guys have been dealing with much simpler objects in the past, and now we're moving into some more complexity, right, in this second half of semester. So, and then finally, how we did the player game object. The player game object has one method, raise shields, nothing else. Enemy has fire bullet, that's all it has different than the player. There's differently specialized. Player can raise shields, enemy can fire bullets, and the boss enemy is an enemy, but it's a specialized, more deadlier enemy that fires fatter bullets. Okay, makes sense? Any questions around this at all before I let you guys go? Because this is all I wanted to do in review. Okay, so if there's no questions, then Wednesday, be prepared for another. Could you please put me in a private room? Sure, I'll do that, Shivani. Give me 1 sec. So stick around. So let's think of it this way. So on Wednesday, I'm going to give you a bit. I'm either going to give you a quiz. Be prepared, because I'm going to either give you a quiz next Wednesday, or this Wednesday coming up, or I might give you a little lab. I haven't decided what to do yet. If I give you a quiz, it's going to be a short number of questions that I'm going to get you to do. It's going to be similar in terms of marks to a lab, right? And the quiz is going to be based on some of the stuff that we talked about last day. It's going to be based on your PowerPoints that I shared with you. And it's going to be open book, of course. And if I do this, you're going to have until Friday to get it done. And I'll even probably give you a couple of attempts if I'm going to do a quiz, okay? So it's not going to be deadly. But it'll give you a chance to review some of this material, because this, my friends, is the basis of what we do going forward. Okay, guys, that's it for today. I'm going to stop recording, and then for anyone else who wants to stick around, I'm going to be here to answer some other questions or to deal with any other concerns.